Our topic for today is about one-sided limits. Okay, let's define first the one-sided limits before we go to problem solving. Now, the definition is the limit of f of x as x approaches a from the left is equal to L if the values of x get close enough to L as the values of x get close enough to a but are less than a. In symbols, we have the limit of f of x as x approaches a from the left is equal to L. Also, the limit of f of x as x approaches a from the right is equal to L if the values of f of x get close enough to L as the values of x get close enough to a but are larger than a. And in symbols, the limit of f of x as x approaches a from the right is equal to L. Okay, now let's try to demonstrate the sided limits in a given figure. So here we have a graph, all right, and a one-sided graph from -1 to positive infinity. And let's consider all the values. Okay, oh, let me change the color. Let's consider all the values from the right side of -1. So here we go. And all the values of x, okay, from the right side of -1. So here, we're going to consider here the limit of f of x, okay, as x approaches -1 from the right. So it only means that at which point or value or function value does this graph approach to, considering all the values of x from from right to left, okay? So from the right. So here, if we're going to consider the trend or the behavior of the graph is approaching, okay, the point -1, 0, okay, from right to left, okay, or from the right of -1. And since when we talk about the function value or the limit of the function, we're talking about the function value here. So which means that the limit, okay, let me just, the limit of f of x, okay, as x approaches -1 from the right is equal to 0, all right? Since that's what we get from the given graph, okay? And this is how we define or how we find the limit or the one-sided limit of a certain function. Now, if we're going to consider the limit or the limit of the other side of the function or the graph, so that's the limit of f of x or the graph, the given graph, as x approaches -1 from the left of -1, so that's coming from here, going to the right, okay? Now, since we can't see any points on the left side of -1, all right, considering the values of x which are on the left side of -1, therefore, the limit or the one-sided limit of this function at -1 from the left is undefined, okay? Or it does not exist. It does not exist, or we say D and E does not exist since there are no points on the given values of x. All right. So now let's apply the definition or the definition and some properties of these limits. So let's consider problem number 1, and let's consider this graph, which is y is equal to f of x, and we have the graph here, color blue, in the xy plane. And let's answer the first problem. The limit of f of x as x approaches -1 from the right. So from the right, that's coming from here to -1. So this is -1. And as we knew, the graph approaches -1, right, from the right. Okay, -1. So it approaches this point. Okay, again, we're talking about the function value. And how about this? The limit of f of x as x approaches -1 from the left. So from the left, okay, we are going to consider this graph, since these are the points that we could see or we can find if we're going to consider the points, the values of x from the left of -1. Okay, so when x is equal to -1. So here, where do we find, or what is the trend or the behavior of the graph? Where does it approach to? Okay, the graph approaches to the point -1, 2. All right, it approaches to the point -1, 2. And again, since we are talking about the limit of a function or the function value, then our answer here is 2. Okay, so it approaches this value of y, which is 2. So that's why the limit of a function f of x as x approaches -1 from the left is equal to 2. Okay, I hope it's clear. And question number 2, try to pause the video and check or answer this by your own, and let's see if we'll have the same answer. So in question number 2, using the graph again, all right, so, oh, I think we have the same problem here. Okay, oh, we have the same problem. Now let's move on. Do we have really the same? Yeah, we have the same problem. So let's move on number 2. Number 3. Okay, so let's consider this graph. We have the limit of f of x as x approaches 0. So he's 0. And from the right, so 0 from the right because of the plus sign here. Okay, it means from the right side of the value of x, which is 0. So we are considering this. Okay, this value. Since there are no graphs here at the bottom part of the x-axis, so therefore we check the upper part and we see that the points are, okay, the points are located on this graph. Okay, so on the positive, on the right side of 0, the graph is approaching to 1. All right, so the function value is 1. So therefore, the graph is, or the limit of f of x access as x approaches 0 from the right is 1. So here it is. Okay, and also the other question here is the limit of f of x as x approaches 0 from the left. So that's this graph, and it approaches 0. Okay, and I hope we got the same answer. And let's solve number 4. So the limit of f of x as x approaches 1 from the left, 1 from the left. So here we go. So we're going to consider this, and it's equal to 2, right? And how about this? The limit of f of x as x approaches 1 from the right. So here, and it approaches -2. Okay, so using the graph, it can be easily seen where the graph approaches 2 on a certain value of x. All right, so these are the values. Let's consider another example here. So the limit of f of x as x approaches -2. Here's the -2 from the right. Okay, from the right, here we go. So we're going to consider this. Well, let's use another color, yellow. Oh, no, not yellow. Let's use blue. Okay, so from the right of -2, so since there are no points on the lower part of the x-axis, we need to check the upper part. And we found here the points on the graph. So this is what we're going to use to solve for the limit of f of x as x approaches -2 from the right. So now where does the graph approach to? So it approaches 3, right? So the answer here is 3. Okay, how about this? The limit of f of x as x approaches -2 from the left. So from the left, -2, here we go. And this is the graph. So therefore, it approaches what? It's 3. So they have the same value. They have the same limit from left to right, all right? Okay, next, number 6. What is the limit of f of x as x approaches 3 from the left? Okay, from the left, sorry, yeah, from the left of 3. From the left of 3, we have this, okay? From the left, it means less than 3. So therefore, since from the left of 3, the values of x can be found in this condition or in this range or domain, therefore, we will be considering this function or subfunction of the piecewise function. So we have 4 minus, okay, 4 minus 3 square is equal to 4 minus 9. That's equal to negative 5. All right. So the graph is approaching to negative 5. Okay. Now you can also use a 2 point. You can also use x is equal to 2.5, 2.6, 2.8, or 2.9, or 2.999, and also 3, and check whatever the value of f of x once you substituted these values of x in f of x, okay? And find the pattern or find the trend on the value of the values of f of x once you substitute this, and you will see that it approaches to negative 5, okay? I hope you got my point there. Okay, why? Because uh, let's consider 3. So 3, that's 9, and 2.999 is close to 3. So you can substitute 2.999999 here, and that's equivalent to almost 9, right? And 4 minus 9 is negative 5. That's why the answer here is negative 5. Okay, here we go. Now, how about the limit of f of x as x approaches 3 from the right? From the right means all the values of x which are greater than, okay, 3. So we're going to consider, or that condition is under this range, all right? And of course, we're going to use this sub function in the piecewise function. So let's consider 3. So that's 2, 3 squared minus 5 times 3 plus 1. So let's simplify this. This is 18, this is 15 plus 1. This is equal to 4. So the answer here is equal to 4, okay? And if we're going to check the two functions, or the limits of the two functions are different values, okay? And again, much better, or if you can't visualize the trend of the graph or the points of the graph here, you may also sketch the graph of this function or the piecewise function, and you will see it clearly there, okay? However, it will take time, or it's a lot of time to sketch the graph compared with just substituting the possible values of x, okay? Or value of x, okay? I hope you got the same answer. And how about number 7? Okay, so the limit of f of x as x approaches negative 1 from the right. So all of the values of x which are greater than negative 1. So values of x which are greater than negative 1 can be found here or here. However, we need to consider this because these are the points which are closer or even closest to negative 1 compared with this values of x, right? So the condition is within this range, okay? I mean, within the domain, the range of the domain. And of course, we're going to consider this function or subfunction. So our x is negative 1, so therefore 4 minus negative 1 squared is equal to 4 minus 1 is equal to 3. So this is equal to 3. Okay, and how about this? The limit of f of x as x approaches negative 1 from the left. So all of the values of x which are lesser than negative 1. So we can find that here. Okay, those values can be found from the range of the domain here. And of course, we're going to consider this subfunction. So since it's negative 1, so therefore let's substitute negative 1 squared plus negative 1 plus 3. That's 1 minus 1 plus 3 is equal to 3. And we got the same value. Okay? So limit of f of x as x approaches negative 1 from the left is equal to 3. All right? And I hope we got the same or equal values, okay, in finding the one-sided limits of the given function. And let's move on to finding the limit, okay, or the limits of the given function. So before we go to problem solving, let's read the theorem first. Now it says here, the limit of f of x as x approaches a is equal to L if and only if. So it's very strong statement because it uses biconditional statement. If and only if its limit from the left and from the right as x approaches a are both equal to L. Or in symbols, now we can find the limit of a given function, okay, with the use of the one-sided limits, okay, the left and the right. Now, how do we use that? We can say, or we can find the limit of a certain function at a certain value of a, where x is approaching 2, if we found a limit of the given function at a from the left or a from the right of equal values of limits. Again, if we found that the limit of f of x as x approaches a from the right is equal to the limit of f of x as x approaches from the left, which is equal to L, then our limit or the limit of f of x as x approaches a is equal to L. In short, guys, when the two-sided limits at when x approaches to a certain value have equal values or equal limit, okay, which is L, or the limit exists and their limits are equal, then the limit of that function is equal to L, and therefore the limit exists. Okay, so let's apply the theorem. So in example number 1, we need to find the limit of f of x as x approaches negative 1 from the right, or we need to find the limit of this function as x approaches negative 1. But before we do that, we need to solve first or identify the one-sided limits from the right and from the left. So here, we're going to identify first the limit. Okay, let me change the color of the pen. So we have the limit of f of x as x approaches negative 1. So negative 1 is here from the right. So from the right is here, right? Okay, and we're going to consider this graph. And as we could see, the graph or the function value or the graph itself approaches the point negative 1, negative 1. And since we're talking about the function value, so the limit here is equal to negative 1. Okay? And how about the limit of f of x as x approaches negative 1 from the left? So we're talking about this direction. And we are going to consider this graph, okay? This graph. And where does this graph approach to? It approaches to the point negative 1, 2. So therefore, the limit of f of x as x approaches negative 1 from the left is equal to 2. Why 2? Again, we're talking about the function value, okay, when we are finding the limit. Now, for us to find the limit of f of x as x approaches negative 1, now based on the theorem, we can only find, or the limit of a certain function exists when the two-sided limits of the same function have equal values. However, in this example number 1, we found out that they have different values. One is negative 1 and the other is 2. Therefore, the limit here does not exist. Or we can simply write D and E, or sometimes we write capital letters D and E. Okay, why D and E? Because the limit here is 2, while the other limit is negative 1. Therefore, the limit does not exist. Okay, the two graphs from both directions, okay, or opposite directions have different values that they are approaching to. So Automatically, it does not exist. Okay, in number 2, we have the same given, and let's talk about number 3. In number 3, okay, we have the limit of f of x as x approaches 1. So we're going to find this limit, but to find this, we need to find the one-sided limits. So let's identify the limit of f of x as x approaches 1 from the right. From the right is here, so it's -2, right? We already solved this a while ago. How about this? Oh, this is from the left. Okay, from the left. So that's here. Oh, sorry. This must be positive. All right. Oh, the negative was misplaced. It should be here. Okay, +1. Here, the limit is equal to 2. Again, the limits are different values. Therefore, it does not exist. And in the graph, we can easily find the limits, right? Look, they are of different values. So therefore, the limit does not exist. Okay, in number 4, okay. Oh my, this is positive, one is positive, and one is negative. So in this case, we need to find the limit of f of x as x approaches -2. So -2 is here, and it's here. So if we're going to look at this, or analyze the figure or the graph, now from the left and from the right, they're approaching to a specific number, which is 3. This is -2, 3, right? Okay. Supposedly -2, 3, if this is heavy, okay? And we can easily say that this is equal to 3. This is 3, by the way. Okay, now let's check if this is equal to 3. Now, let's find out the limit of f of x as x approaches -2 from the right. So from the right is here, this is -2, and it approaches 3. And here, the limit of f of x as x approaches -2, it's here, and from the left. So here we go. So this one is approaching 3 as a function value. Therefore, it's 3. Again, by theorem 1, since the two-sided limits have equal value, which is 3, therefore the limit of the function as x approaches -2 is equal to 3. And we can easily see that here, right? They're approaching on the same value. Okay, so I hope we got the same answer. And in number 5, uh, let's find the limit of f of x as x approaches 3. Okay, and let's check that here. So we need to find the sided limits, the one-sided limits first. Okay, the limit of f of x as x approaches 3 from the left. So when x is less than 3, so we can use this, right? All the values of x here are less than 3. So we're going to use this function or sub-function. So that's 4 minus 3 squared is equal to 4 minus 9, which is equal to -5. Therefore, this is -5. And how about the limit of f of x as x approaches 3 from the right? So those values of x which are greater than 3. And that's here. All right, so we will be using this function. So 2 times 3 square minus 5 times 3 plus 1 is equal to, okay, this is 9, 18 minus 15 plus 1. And this is 3, this is 4. Okay, so this is equal to 4. Right, so now look at this. The one-sided limits are of different values, -5 and 4. Therefore, the limit of f of x as x approaches 3 does not exist. Okay, it doesn't exist. Okay, and number 6, now let's have the absolute value. How do we solve for the limit of the absolute value? So we need to identify or determine the specific uh, functions, okay, or the sub-functions of this absolute value function. So let's identify the sub-function. Now, if x is greater than 4, so x is x minus 4, right? positive. So x is greater than or equal to 4. And if x is less than 4, now this becomes negative x minus 4. All the values will become negative, correct? So again, if x is more than 4, the values will always be positive. That's why we just copy this, because it is always positive. And if x is less than 4, then the values will always be negative. Since it is an absolute value, the answer should always be positive. We need to multiply it by negative 1. Okay, so we have now our subfunctions in a given absolute value. So we're going to consider our limits, okay, using these functions. But then again, I just, what's this? I just analyzed what are the possible subfunctions of this absolute value. So let's now find the limit or the one-sided limits of this function, okay? So x, the absolute value of x minus 4 as x approaches 4 from the right first, okay? And here, the limit of the absolute value of x minus 4 as x approaches 4 from the left. Okay, let's consider this first. So x is greater than 4. So here we go, we got this. And we will be using this. So therefore, this is, okay, it approaches 0, right? So the values, when the values of x approaches 4 from the right, then the values of the function approach, okay, to 0. And how about this? When the limit of, or find the limit of x, absolute value of x minus 4 as x approaches 4 from the left. So from the left is here, okay? And what do we get when the value of x approaches 4? What do we see? What kind of trend do we get when we sketch the graph? Or what are the trend? What is the trend of the values when we substitute the values of x here? And of course, this becomes, okay, we will be using this subfunction. This becomes, the value approaches 0. And since there's negative, so negative times 0 is 0. So the function, I mean, the limit of this function is still 0. And if we're going to look at it, now they're both equal. Therefore, the limit of the absolute value of x minus 4 as x approaches 4 is equal to 0. Why 0? Because the one-sided limits are equal. They're both 0, okay? And if you're going to sketch the graph of this function or absolute value x minus 4, that's 4 here. If this is 4, then the graph looks like this, right? So this is the left-hand side of 4 and the right-hand side of 4, and they're both approaching 0, okay? So you better know how to sketch the graph, and you can easily identify the limit of that. Okay, how about number 7? And again, to find the limit of x plus 3 all over the absolute value of x plus 3 as x approaches negative 3, again, we need to consider we need to consider identifying the subfunctions of this. So let's use swipe. Okay, so I will, okay, identify the subfunction. So here we go. So we have, if x is greater than 3, negative 3, okay, if x is greater than or equal to negative 3, what's happening to the graph? Okay, it becomes what? It becomes positive, right? 0 to positive. Therefore, this is always positive. X plus 3, oh, this can never be 0, okay? Because it becomes undefined. So this becomes x plus 3, which is equal to 1, right? And how about if x is less than negative 3? Okay, here we go. If x is less than negative 3, of course, this is x plus 3. Oh, wait a minute. My pen is, okay, here we go. So x plus 3, all over, right? If x is less than 3, the inner value becomes negative since it's absolute value, so we need to convert it to positive, right? By multiplying it by -1. So therefore, this is x plus 3. Okay, here we go. And if we're going to simplify, this is equal to -1. Okay, here we go. So we have two possible values, 1 and -1. Now the question is, how do we find the limit of this function? So from -3. So we're going to find the limit of the function as x approaches -3 from the left. Oh my God, my pen doesn't work well right now. Okay. Okay, so we have uh, as x approaches -3 from the right, therefore all of the values of x greater than -3. So we are considering this, and the answer is 1. Correct? All right, how about the other? So the limit of f of x as x approaches -3 from the left. So from the left, all of the values of x which are less than -3, so here we go, and it is always equal to -1. Since the values are not the same, therefore, the answer here is does not exist. Okay, and I hope we get the same value. And I hope you understand how to find the limit of certain function. Okay, and if you have question, just comment your question under this video. Thank you.